Hello, welcome back. Final lecture on trigonometric identities. I think that's lecture 4, and we're going to deal with the beasts. I have questions 33 to 40. These are quite tough, I think. It's just practically enrichment. You're not likely to see things like that on your exam. However, if you can do those, your trig is tip-top. Okay, this is for year 13, of course. Without wasting any time, let's go straight into this. So, question number 33. We need to prove the identity that the sine of 3 theta. I will move it out of the way, guys. I have my board is not big enough to actually fit it in. So let me just copy it. And my eyesight does not help, so I have to get really close to the question. Cos 3 theta over sine theta, and this is identically equal to 2 lots of the cot of 2 theta. This is the identity. Sine 3 theta over cos theta plus cos 3 theta over sine theta is the same as 2 cot of 2 theta. How do we deal with the sine of 3 theta and the cos of 3 theta? Do we use, the other day we did find identities for example, the cos of 3 theta. You should know, or no, you shouldn't know. I take that back. Of course, you shouldn't know, but you can actually prove that the cos of 3 theta is the same as 4 cos cubed theta minus 3 times the cos of theta. This you can prove. You could be asked to prove that, and a similar identity for the sine of 3 theta. If you put those ones in there and divide by sine theta and corresponding for the sine of 3 theta, it will actually work, but it's going to be very painfully long. So there must be a quicker way and a better way of dealing with this identity, and in fact there is. We're going to add the fractions on the left. So we're going to start on the left and add the 2 fractions. Common denominator, cos theta, sine theta, and the numerator, probably didn't leave enough space, is the sine of 3 theta times the sine of theta plus the cos of 3 theta multiplying the cos of theta. At first glance, it doesn't look very pretty, and we need to focus on this numerator. What can we do about that? This is actually an identity. We just need to spot it. This is actually the identity for cos of 3 theta minus theta. Let me just write it first of all, and then we are going to look at it. Cos theta sine theta. The denominator, we're not doing anything to it. Imagine we had cos 3 theta minus theta. That's the cos of A minus B. We should have had cos 3 theta times the cos of theta plus the sine of 3 theta times the sine of theta. It's all there. So of course this now gives us the cos of 2 theta divided by the cos of theta sine theta. What's our target? We need to see what we're heading for. We need to keep, that's the top of the cot there. So we just need to manipulate the bottom, multiply top and bottom of the fraction by 2. So we got 2 cos of 2 theta divided by 2 cos theta sine theta, which of course now it's another identity we should recognize. So that is in fact the sine of 2 theta, which gives us the 2 lots of cot of 2 theta. Very badly written. I was going to write tan there for a second. 2 lots of cot of 2 theta, which of course it's RHS. So this is the identity proven. So that was number 33. Question 34 coming up next. Let's see what it's actually saying. Let me move the piece of paper on this side. Okay, the sine of x divided by 1 plus the tan of x is in fact identical to the cos of x 1 plus cot x. We've done a similar one, I think, on lecture number 3. It was slightly easier than this. It's fairly symmetrical. It should be obvious that it doesn't really matter whether we start left or right. So let's start on the left, but what do we do? It's very difficult sometimes. We're getting harder to explain what's going through one's head. It comes with the experience. I can call it gut feeling. I'm going to create from a sine, I'm just looking at the top, a cos. How on earth I'm going to do that? Okay, I'm going to do it as follows. I'm going to have the sine there. I'm leaving some space underneath it. I'm going to have the tan, the 1 plus the tan of x. So sorry, this isn't, let me just put the line there just to make sure, because it looks like they mixed up the two lines there. And what I'm going to do, I want to lose the sine. So I will lose the sine, of course, by dividing top and bottom by the sine of x. That's acceptable. So that has gone, that gives you the sine. So it's 1 at the moment on the top. And then I want to create a cos. So I'm going to times each term now by cos. So the 1 will become 1 cos of x. And then I have a cos of x here. So now I need to tidy what I've got left. Let's look at it. First of all, this will be gone. So I constructed, my thinking was to create a cos of x on the top of the fraction. Hopefully the rest will make sense. What do I have in there? Very badly written. Let me write a little bit clearer. That should be 1 times the cos of x. So this should be right with my hand, but let's do it. So that's cos of x divided by sine of x. That's actually rather nice, because that is in fact cot x, which we got in there. Is that a 1 is the question? And the answer, of course, it is, because if you look carefully, this lump is a tan of x times a cos of x over a sine of x, which of course is the same as timesing by cot, or perhaps it's easier to see if we write the tan maybe as sine x over cos of x. That's my tan, times of course cos x over sine x, and the game is over. Okay, so this is in fact plus 1, which is equal to our 8s. So this didn't require an awful lot of working, but it requires some clever thinking to actually see how we're gonna go from one side to the other. Okay, so I did look at the answer, and of course I created the answer somehow, and once spotted is actually 2 lines, this particular one. So 33, 34, 35, it doesn't look too bad, but let's have a look at it. Famous last words. I hope I can do it now. Cot squared x minus tan squared x is identical to 4 cot of 2x cos sec of 2x. Cos sec of 2x. I feel like we ought to start from the right for this particular one. I don't like going from single x's to 2 x's. I prefer to break 2 x's. So we're going to start from the right. Okay. First of all, let's write it in terms of sines and cosines, because it's easier. So we're going to have 4. The cot is of course cos of a sine, so it's going to be a cos of 2x over a sine of 2x. And the cosec, of course, is a 1 over sine of 2x. So this is how far we have gone with this particular expression. Okay, simplified. 4 cos of 2x, and at the bottom I've got the sine of 2x all squared. It's probably better if we expand this and write it as 2 sine x cos x. That's just this bit here, but of course it's 2 of them multiplied together squared, so I have something which looks like that. If we continue, I'm definitely going to need to break that cos of 2x. So let's start by putting a bracket there. I'm not quite sure what I'm going to put in there, but I'm squaring now the denominator, and that of course will give me a 4 sine squared x cos squared x, and the 4's will cancel very nicely. And now I'm looking at my answer, the target on the left. I got a cot squared minus tan squared. I can see which version of the cos of 2x we need there. We need the version that says cos squared x minus sine squared x, because once we split the fraction, we will get the desired result. So if you can pick, so the 4's have now gone. I'm gonna just write them off with my hand. so they don't distract us. We're going to have cos squared divided by all of this. The cos squares will cancel, so it's going to give me 1 over sorry, I beg your pardon, what's this? I'm making a mistake in there. Cos squared divided by that is 1 over, no, it's correct, 1 over sine squared x. And then if we split the other fraction, we're going to get the sine squares will cancel now, so we got 1 minus cos squared x. What happens next? These particular expressions, we know them with different names, of course. Okay, this is the cosec squared of x minus the sec squared of x. This is not what it should look like, but we know how to change cosecs to cots and secs into tans, squareds, of course. So a cosec squared is 1 plus a cot squared x, Pythagorean identity, minus the sec squared is 1 plus tan squared of x. 1 minus 1 will cancel, and I think we're going to get from this cot squared, take away tan squared, which of course is our left hand side. Identity number 35 is being destroyed. Number 36, very long and messy, this one. So let's clear the board, because this takes a lot of space. I cannot really fit 2 of at a time. Very, very long fraction. 2 sine x cos, is it cos x? Yeah, cos x minus cos x. That's of course an identity in its own right, so that is might be a clue, or it could be a distractor, something to take our attention away from what we need to do. 1 minus sine x plus sine squared x. Now there's more stuff, believe it or not, minus cos squared x, and the target is a cot, of x. Well, quite clearly we don't need double angle in there. This is a double angle. Let me just double check I copied it correctly. We can go to double angle there. That's of course the sine of 2x. We don't want to do that. So let's start from the left, because of course this is where all the action is with all this stuff. And let's look at it and just see if we can spot a few things. What I spot on the denominator is 2 items, 2 things. 1 minus cos squared is a sine squared. Together with sine squared, it will make 2 sine squared. Also, cos squared x minus sine squared x is negative cos of 2x. But this produces lots of 2x, and I don't like it. So I'm going to start with the top, and rather than writing this as sine 2x, I'm going to factorize the cos. And I will tell you what I'm thinking. The target is a cot of x, which is cos of a sine. I hope this is the cos that I'm going to be left with on the top. So I just hope the bracket I'm creating will cancel, and hopefully will leave me a sign at the bottom. I just need to combine my items at the bottom correctly. So I'm going to write next, I'm going to underline in, let's say, a different color pen, the quantities that I'm looking at. So 1 minus cos squared x, this will give me a sine squared x, year 12 identity, plus another sine squared x, which was there, so that will make it 2, minus a sine of x. Does that work? Does that give me the right thing? I think it does. It's actually quite simple. Unless I'm underestimating it, not too, sorry. I'm going to factorize the sine of x at the bottom. 2 sine x minus 1. Yes, it's just silly, really. It's not as hard. Just a lot of stuff. Try to stress you out with loads of information overload in the hope that you will crack up. So this is a cot x, which of course is now the right hand side. Not that bad, this one. That was, I didn't put a number. This was number 36. And we got to go up to 40, and our education on trig identities will then be complete. Number 37. That I don't like the look of. Okay, 37, it says that the tan of theta plus pi over 4 is identical to the sec of 2 theta plus the tan of 2 theta. I think that actually scares me a little bit when I'm looking at that. Where will I start? Well, definitely not from the right, because somehow I need to just get rid of this pi over 4. Tan of pi over 4 is of course 1, which I'm gonna get off, well, you can get off your calculator of course. So I'm gonna start from the left and just hope for the best. The compound angle for tan A plus B is what I'm using next, which is of course tan A plus the tan of B over 1 minus tan A tan B. So we're gonna get the tan of A, which is the tan of theta, plus the tan of pi over 4. I'm not gonna write it now, we are beast level. Just take your calculator. Tan of pi over 4 is of course 1. Try to cut a few of the steps because there might be quite a lot of things to do on this one. And then I've got 1 minus the tan of theta times the tan of pi over 4. The tan of pi over 4 again is 1. So that's not a difficult step. It's just basically applying this identity and substituting the tans of pi over 4 for 1s. So what do we do next in this particular question? Let me just, for something like this, I've got secs in there and tans, and I'm gonna go to double angle. So I prefer to see them in sines and cosines because I can recognize these quantities better if I'm in sine and cosine. So I'm going to write it as 1, I'm going to write this bit first, plus sine theta over cos theta. And then at the denominator, 1 minus sine theta over cos theta. What happens next? Well, get rid of the double fraction. So I'm going to have multiply top and bottom of 4 quantities by the cos of theta. So cos theta here, the cos theta here will cancel me to plus sine theta. And here I'm going to get a cos theta. Oops, why am I writing square? It's because I'm thinking of the next line actually. Cos theta minus sine theta, because I can now see what is the plan for this particular identities. I need to multiply top and bottom now of this fraction with the correct quantity. I need to create, if you look at what these things are, this is 1 over the cos of 2 theta, that's your sec of 2 theta, plus sine 2 theta over cos of 2 theta on the same denominator. Essentially, they both have cos of 2 theta. And the cos of 2 theta, one of the versions, is cos squared theta minus sine squared theta. So keep this in mind, and this motivates my next step. I'm going to create a difference of squares. So this is what I have there already. I'm just merely recopying it. Cos theta plus sine theta over cos theta minus sine theta. I'm going to create a difference of squares. Oh, here I go again. My brain is misfiring. Sorry about that. I'm getting old. Plus the sine of theta. And of course, the same thing on the top. What happens? Difference of squares. Cos squared theta minus sine squared theta. Isn't that beautiful? Because of course, I'm looking at creating this expression. Cos squared theta minus sine squared theta. Sorry if you heard the squeaky noise on my mic. It was my minger going like this on the board. You just might have thought I broke wind or something. It wasn't that. Okay, so let's square this top. So it's going to give us a cos squared theta plus 2 lots of sine theta cos theta plus sine squared theta. And I think everything now falls into place. Don't have enough room to sit so you can see the board. Cos squared plus sine squared is 1, those two. This is a double angle, which of course is the sine of 2 theta. So this is the one. And this is another identity, sine 2 theta. The denominator is, of course, another identity. It's, of course, the cos of 2 theta. Split your fraction, and the game is well and truly over. 1 over cos 2 theta plus the sine of 2 theta over the cos of 2 theta. And that's, of course, the sec of 2 theta plus the tan of 2 theta, which of course is RHS. So this one, I think it was quite a tough one. I know it might have looked easy. Anything in life, any skill, it's not about maths, anything in life, when the man who knows how to do the job does it, it looks very, very easy. It's a very different ball game when you try it yourself. Trust me, this particular question is not easy at all. In an exam, this will just destroy, really. It's not easy to see all this kind of manipulation. Essentially, it tests all the identities practically that a student would have done by the end of year 13. And not only you must know them, but you must be able to see them. And that's the hardest bit, of course, in all of this. Number 38, another messy one, similar to 36. I hope it's easy, because this one's actually annoying me. I don't enjoy those ones. They look loads of stuff in the hope that it's hard, or it will make it harder by just throwing too many bits at you all at once. So 2 sec squared theta minus the cos of 2 theta minus a 1 over 2 tan theta plus the sine of 2 theta is a mess, is equal to this. All of this should give us just the tan of theta is equal to tan theta. So we're going to get with sine over cos. Where do we start with this? First of all, we definitely need to break the double angles. But we also have a tan in there, which is a pain, because that's going to be a 1 over, not 1 over sine over cos. It's just loads of stuff in there. Let's start from the left. And let's hope we don't make any mistakes. This is going to be very messy. First of all, switching into sines and cosines, I'm trying not to waste too much time. 2 over cos squared of theta. This is my sec squared. Minus bracket, minus 1. I'm going to fill that bracket in a minute. 2 sine theta over the cos of theta. That's my 2 tan. And the sine of 2 theta is, of course, can only be 2 sine theta cos theta. The question is now, what do I use for that cos of 2 theta? I need the version that gets rid of this 1. It's 2 cos squared theta minus 1. Okay, yes, that's the one, because minus 1 is plus 1, minus 1 will cancel. Okay, what happens next? A bit of a tidy. First of all, plus 1 minus 1 cancel. So I'm going to end up with 2 over cos squared theta minus 2 cos squared theta over 2 sine theta over cos theta plus 2 sine theta cos theta. Very unpleasant, very untidy as well. I don't want to waste a line. 2, 2, 2, 2. So my cloth will do the job, hopefully well enough. So that 2 will go, and this 2 will go. So at least that's a little bit simpler. So a bit of luck there. To simplify that, I just need to get rid of this double fraction. I'm going to multiply top and bottom, or 4 terms, by the cos squared of theta. This will tidy everything. So I have to be careful, because it's very easy to make mistakes. At the moment I got a pounding headache on top of that. So this is going to be a 1 when I times by cos squared. This is going to go cos to the 4. And this is going to be a sine of theta times the cos squared. It will leave me with the cos still there. and times by a cos squared is gonna change this cos into a cos cubed. This looks even worse now. And what's our target? Sine of a cos. Okay, I see a few things in there, so let's I don't know if that's going to be the sensible thing. So this, you might, if you're copying, please do not copy it, because I'm not sure if that's the right way. I'm going to factorize a sine cos from the denominator first of all. So a sine theta cos theta, I need to see it first of all, so that's going to give me a 1 plus sine cos gone from there. Yes, it's correct. So you can start copying if you are. This works because I can see my numerator now, the difference of squares. So that's 1 minus cos squared theta, 1 minus cos squared theta, 1 plus sine squared theta. Okay, can you see this difference of squares? Because to the 4, you can think of that as 1 squared minus the cos squared of theta all squared. So that's 1 plus cos squared theta. I did warn you today, it's the beasts are now the hardest identities that I could possibly find. Well, I have some a little bit harder than that, but they're very, very lengthy. So this now is what I'm getting. Target is a tan. It's there because, of course, 1 minus cos squared is a sine squared. And after that, we can give it to a year 12 to finish it off. The sine squared will cancel there. And we got sine over cos, which, of course, is the tan of theta, which is RHS, because we started from the left. Okay, that was number 38. I think that was also tricky, but I found the previous one, the one with the tan theta plus pi over 4, personally, I think that's actually harder than this. Okay, number 39. Oh no, that's a mess. This is not hard. You know, we done the cos or the sine of 3x. I think it was a cos actually we did the other day. This is the tan of 3x. What is the tan of 3x? That I don't actually know by heart, so I have to derive it myself. The tan of 3x is apparently 3. All I know, these identities have a 1 at the bottom left. So it's 3 tan x, all the tan multiple angles, minus the tan cubed of x. And it's going to be even at the bottom, minus 3 tan squared x. Okay. For this, we're going to start from the left. Try to keep track of the work because it is a little bit messy, this one. We're going to write the tan of 3x as the tan of 2x plus x. And I'm going to write up here purely for reference so you can follow the workings. They're a little bit messy. They're not hard. This question is not hard. It's just that you have to keep a clear head and don't make a mistake. The tan of a plus b is the same as the tan of a plus the tan of b. I'm going to move the piece of paper on this side, over 1 minus tan A tan B. And I'm also going to need the tan 2x. So the tan of 2a is identically equal to 2 tan A over 1 minus tan squared of a. We're going to need these identities within the proof, so I'm writing them up there so it's easier to follow. So first of all, I'm doing the tan of a plus b, where this is now the tan of a, which is 2x, plus the tan of b, tan of x, over 1 minus the tan of 2x times the tan of x. So this is my a, this is my b, and I've done nothing different than using this identity. Now within this, I have to use on this term and this term, this identity. So big fraction line, the tan of 2x is 2 tan x over 1 minus tan squared x. That's this lump plus the tan of x. and then I have 1 minus, let's write the tan of x first, this bit here. The tan of x times the tan of 2x. The tan of 2x is this. 2 tan x over 1 minus tan squared x. And now I need to simplify this. I'm going to multiply, as per usual, top and bottom of this fraction. 1, 2, 3, 4. This is not two separate things, one thing. 1, 2, 3, 4. But the quantity that kills the denominators, this bit here. And the quantity in question is, of course, 1 minus tan squared x. So I'm not recording, I'm not writing things down. When you're doing this kind of work in an exam or whatever for your notes, please write there, multiply top and bottom in words, so everybody that's looking at that is actually following what you're doing. So that's equal to, timesing that, it'll give me 2 tan x on the top left, plus the tan of x, which is there, needs to be times by that as well, bracket 1 minus tan squared of x. This one needs to be times by 1 minus tan squared x, so 1 minus tan squared x it is. And all of this needs to be times by 1 minus tan squared x. I'm writing so you can see this one, but then I'm going to rub it off. This is one lump, so it will just cancel this denominator, and it will leave me minus tan x times 2 tan x. So I hope you can all see it correctly, so we don't make mistake with this term. So it's going to be minus 2 tan squared of x. After that's a tidy, and I hope we got our answer. 2 tan x plus a tan x minus a tan cubed of x. There's our answer up there. And at the bottom, we can actually write straight away. 1 minus 3 lots of tan squared of x. And you will allow me to write RHS. I don't want to write this again, just to put these two tans together to a 3. Okay, let's rub this off if you want. And just put there a 3. And we're done. And this is the identity completed. That was number 39. Not difficult, this one. This is messy. I mean, if your algebra is good and you take your time, of course you will get the answer. Is not a problem. It can be done also if you write your tan of 3x in sines and cosines. I wouldn't personally recommend it. I will tell you to actually work with this too. But of course you need to know all your standard identities. Do I need perhaps this up there? Probably not. So let's rub this off. And number 40, please don't be too hard. Oh God. Sine of 4 theta minus 8 lots of sine cubed of theta multiplied by a cos of theta divided by the sine of theta apparently is 4 cos of 3 theta. This is fairly nasty. Initial thoughts, apart from saying fairly nasty, and why I said fairly nasty, this doesn't scare me too much, because I'm just going to give you a little bit of an analysis of sine 4 theta. Sine of 4 theta is 2 sine theta cos 2 theta. This of course will be breaking down to 2 sine theta cos theta, and this, if you need to break it, it'll break. It's not a problem. You'll get loads of thetas. The question is, how on earth you're gonna know that you reached the cos of 3 theta? I guess if you're somebody like me, you can actually say, okay, the cos of 3 theta is the same as 4 cos cubed theta minus 3 cos theta, and when you reach that, you say, I'm done. I don't think they will believe in an exam that you know this, because you might just tidy this up, you come up with this expression, and then you don't know what to do, and you say equal cos 3 theta, and it just happens to be correct. I don't think they will be saying, yeah, okay. Not many people will know this. So the alternative is perhaps to tidy the left and then derive the cos of 3 theta. So we have proven, first of all, that this is in fact that, and hopefully break this down and come up with the equivalent. So basically we already have gone from left to right and then from right to left and meet somewhere in the middle. Okay, is there anything else we can do there? There are some other patterns. In fact, one of these patterns is very difficult to explain what I'm thinking at the moment. It will take too long. We did use today, which is somehow using the compound angle identity backwards. Sometimes it does occur in certain themes. And I just hope that this is here as well, because this will save a lot of time. So we're going to start from the left. I'm not going to prove this identity, okay? I did prove it the other day, and if I have to, I'll do it again if everything else fails. So let's have a look at what else we can do. The sine of 4 theta, I already mentioned. We can write it as 2 lots of cos 2 theta sine 2 theta minus 8 sine cubed theta cos theta. Notice there is no denominator on the right hand side, which means we should really cancel this sine theta. This is cancelable if you want from there, but of course not from there, but we can if we break that further. So let's move on and write this as 2 cos 2 theta bracket 2 sine theta cos theta. This is this item on its own, minus 8 lots of sine cubed theta cos theta divided by, of course, the sine of theta. Okay, where do we go from there now? Let's, of course, get rid of this sine all the way through. So this is going to be a 4. Let me just use a red pen to cancel the sine. So the sine will cancel from here, and this is going to become a square. So we keep track of things just in case we double count anything. 2 times 2 is 4, and we have 4 cos theta cos 2 theta. This is not too bad, actually, because this can actually, you know, the cos of 3 theta, if we write it perhaps as cos 3 theta is the cos of 2 theta plus theta, this is cos 2 theta cos theta minus, we have a minus there, that's good news, sine of 2 theta sine theta. So if we come up with something like this, we're done. So at the moment I've got bits which look like that appearing. Let's continue. Minus 8 sine squared theta cos theta. The denominator, of course, has gone, so we don't have anything else. Okay. What we would like to have in here, we would like to have a sine 2 theta sine theta. It's there. It's we just need to rewrite it. I think it will work. I just hope the numbers are correct there. I think they are. I'm going to I'm not going to write 1 minus cos squared for that or anything. I'm going to write it as sine theta. And now I made a little mistake there. I will correct. No mistake. It's not that. I don't want it as an 8 in there. I want it as a 4. So that's going to be a 4 and the 2 in there. So just checking that everything is correct in there. 4 times 2 is your 8. There's your sine squared and there's your cos. But this is now very, very special. And probably be a good idea, so we don't have to write a lot. Pull out the 4 from both of these terms. Use a square bracket. And we're having the cos of theta times the cos of 2 theta minus, the 4 has gone outside. And this is now the sine of theta. And this, of course, is the sine of 2 theta. Isn't that beautiful? Okay, this is what we want. And of course, this is the expansion of double angle of the cos of 2 theta plus theta. So we're going to write that is actually cos of 2 theta plus theta. We do have a 4, yes, the 4 is there. So it's 4 cos 3 theta, which of course is RHS. Relief. Again, I think that was fairly tough to actually see. We're very, very lucky, I guess. He's having stars. I mean, that's a 5-star apparently. So no wonder it felt tough. Okay, this was the end of the lecture. Lecture number 4. No more on trig now on identities. I've done something from the very basic to the ridiculous, if you want. I hope you find it useful. Sometimes looking at things live, how things are being manipulated. Okay, I hope it helps, and I hope you found all of this useful. Okay, I will see you very soon. Who's laughing now? I certainly am. Over.